Yeah, welcome to EASYDONE Tutorial Academy. Today we'll be looking at scalars and vectors quantities. Quantities in physics are divided into scalars or vectors. Quantity is divided into scalars or vectors. So when we say scalars quantities are quantities that have only magnitude but no direction. While vectors are quantities that have both magnitude and direction. Example of scalars quantity are length, mass, time, speed, distance, temperature, energy, work, volume, volume, density, pressure, and charge. Electric charge. All these they only have magnitude. And magnitude means size. You can only measure them with no direction. So when I talk about vectors, we say vectors are quantities that have both magnitude and what? Direction. Examples of vectors are what? Displacement, velocity, acceleration, momentum, impulse, electric field, and force, weight, magnetic field, magnetic field. So all these they are um, vectors quantity. They have both magnitude and direction. So a vector quantity is represented by a line with an arrow on it. So if you see something like this shows it's a what? It's a vector. This shows is a vector. This shows is a vector. This shows is a vector. So there is a difference between it. You see this, they all means vectors, choosing a direction. This is magnitude and this is what? Direction. So when you say an arrow in physics, it means two things. This one is called tail and this is what? Head. And that is why if someone want to give a direction and you don't want to see the person, maybe this person is doing a naming ceremony or something like that, they can just have a paper and they will draw inside it and they have something like this and you'll be following that direction until you get to where you are you are going. So that is about definition of both scalars and vectors quantity. Now let's look at addition of vectors. Addition of vectors. So how do we add vectors together? Vector addition means combining two or more vectors to get a resultant vector. So when you have A, vector A plus vector B, then you have what you call resultant vector R. So it can also be vector R resultant vector is equals to vector A plus what? Vector B. So how do we solve addition of vectors? There are different methods of finding vector addition. The first one is triangle method. Triangle method or triangular method. We can also call it head to tail method. Head to tail method. So how do we do that? The first thing is place the tail of the second vector at the head of the first vector. Place the tail of the second vector at the head of the first vector. So if this is the first vector, vector A, and then this is the second vector. So place the tail of the second vector. This is the tail of the second vector. Place it at the head of the first vector. So then what you are going to get from here to here is your resultant vector. This is a triangular method. So 2, the resultant vector is drawn from the tail of the first to the head of the last, and it can be seen like this. Take for instance, you have, if a person walks 3 meter east and then 4 meter north, what is the resultant vector? A person walks 3 meter east, so we all need a starting point east. This is the east of the person, 3 meter. He walks 3 meter to the east, and then, so in bearing and distance, when you hear then, it means he stop and then continue. So 3 meters stop here, and then 4 meter to north. So this is the north, 4 meter. So how do you now find the resultant what? Displacement. So this will be your displacement, which is what? Our R. So according to this now, if you have A, B, C, of course, your resultant what? Displacement will be what? Using Pythagoras theorem, because this is 90 degree. So you'll be having what? Square root of what? 3 square plus what? 4 square, give you what? 5 meter. That is how to find that using triangle method. The second method is parallelogram method. If two vectors are represented by two adjacent sides of a parallelogram, the resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from the point of intersection of the two sides. That is what the law of what? Law of parallelogram vector states. So if two vectors are represented by two adjacent sides, this vector represented by this vector, another one represented by this. These are vector B, vector A. So if you want to turn this to parallelogram, extension will come in. You extend it to form a parallelogram. Remember, in parallelogram, the two opposite sides are what? Parallel. Something like this. And since it is a parallelogram now, so the resultant now in both magnitude and direction is formed by the diagonal. By the diagonal. So this is our resultant vector of vector A and vector B, which can be written as what? Vector resultant vector is equals to vector A plus vector B. It can be either up or down. It still means the same thing. So look at another one. If you have a vector B being drawn, then we have a vector A drawn like this. Of course, if there is an extension to form a parallelogram, so an extension here also, then we have this. So we are going to get our resultant vector from here by coming back. That's the word A minus B. So here, this will be our minus B, which is the opposite direction towards the what? The vector B. So the vector of minus B is equal in magnitude to what? To vector B, but in opposite direction. That is why if you are playing a table tennis on a flat table, you pass it to your opponent, you also pass it back to you. So you are working oppositely. So this is what both of you are doing, pass to pass. So that is you are following what? A vector there. So also, how do we now get the parallelogram law of vector? The method, the first one is Place both vectors tail to what? Tail to tail. Of course, this is one, this is tail. The second one, tail. So tail what? To tail. Complete a parallelogram. Complete a parallelogram. So complete it. Then the diagonal of the parallelogram from the what? From the common tail, give the resultant vector. So the common tail is this. So this is a what? Resultant vector. That is how to solve a parallelogram law of vector. So in solving problems on parallelogram law of vector, you have to take note of this or take this into consideration. Number one is using cosine formula. If you could recollect, so we can use cosine formula to solve our parallelogram method of vector. So if we have a vector with size ABC where B makes an angle theta, so we have something like this. So if your vector forms something like this now, of course, is your A, this is your B, this is your C. So we're having small a, small b, small c at angle theta. So that is it. So if you want to find the resultant vector of this diagram, that would be c squared is equals to what? A squared plus b squared minus 2ab cos theta or cos c. Cos c. So this is the formula to use when you are dealing with what? A parallelogram that results to obtuse triangle. Okay. Another one is using Pythagoras theorem. Pythagoras theorem. I know that the Pythagoras theorem only work with what? Right angle triangle. So if you have a resultant vector that results to 90 degree, this is one, this is a vector, and this is another vector. So the resultant of the two vectors, this is A, this is B, this is what? C. So I'll be A, B, C. So the resultant of both of them will be what? C square equals to A square plus what? B square. That will be C is equals to square root of A square plus what? B square. And that is how to solve that. The third method is a polygon method. Polygon, from the word polygon. So polygon means what? Any angles or shapes that is what? More than two. That is why a polygon starts from what? Triangle. Tri means what? Three sides. So chord mean what? Four sides. So the rhombus, parallelogram, rectangle, squares, kites, they are all what? Polygon. Pent means what? Five sides. Five sides. Pentagon. X, six sides. X, seven sides. Oct, eight sides. Non, nona, nine sides. Deck, decagon, 10 sides. So there is a possibility that your vector resulted into more than four, directions. So if you have that, how do you solve it? The first thing is we use polygon method when adding more than two vectors. Place vectors head to tail in sequence. Place vector head to tail in sequence. The resultant is from the tail of the first to the head of the last. So if you have something like this now, so this just turn like this. So you start from what? Tail. We said the resultant is from the tail to the first, of the tail of the first to the head of the last. Tail of the first to the head of the last. So you have to be careful starting from the what? Origin. You'll be taking them one after the other. We are going to talk more about this when we get to resultant factor. Okay, now the next method is we call it mathematical method. Mathematical method or component method. Component method. How do we do this? We use this when vectors are given with angles. So when you have angles, 35 degree, 40 degree, 66 degree, 31 degree, something like this. So you are going to take into consideration mathematical method. So how do we do that? The first thing is resolve each vector into horizontal and vertical axis. It's like this now. So you have something like this. So you are going to take into consideration. Normally we know that our direction is into two. This is our x direction. This is our what? Y direction. So positive y, negative y, positive x, negative x. So you first of all you resort to them into x axis and then y axis. Then number two you need to consider is that add x components and y components separately. Those that form in y component, add them separately. Those that form in x component, add them separately. Then the next thing is you find the magnitude and direction of the resultant. So the formula is given as the resultant of the vertical axis is equals to vector of vertical axis of A plus the another vector of what? Of the horizontal axis of B. So if you are dealing with vertical axis, resultant component of y axis, that will be what? A of y plus what? B of y. And then if you ask to find the resultant of both now, since we've already resolved them into what? Horizontal axis and then y axis. So the resultant vector will now be what? Square root of what? R square x, that is resultant axis square plus what? Resultant of y component, everything square. And then if you have to find the magnitude, this is the formula for magnitude. You now have to find the direction. Direction is what? Your theta. Your theta. And remember that your theta is written as gradient in mathematics. So your theta is what? Tan inverse of what? Resultant vector of y component divided by resultant vector of x component. With this, you won't have any difficulties in dealing with your calculation in mathematical method using or finding vectors or resultant vectors either in vertical axis or horizontal axis in physics. Okay, there are some special cases, so all what you need just memorize this method. Then if the two vectors you are given they have the same direction, maybe north north, or I get it now, or what, south south, or east east, or west west, just do what, add both of them. So 3 meter north, 4 meter north, that will be 7 meter north. So you have different opposite direction, north east, um north south, east west. You do what? You subtract. And that is why we're having absolute. Absolute, that's to tell you that if you get negative, the negative you are getting here means it was towards negative direction, but your final answer will not be negative because a vector cannot be what? Negative. So that's meaning why we are putting absolute. This symbol means absolute value. The perpendicular vectors. So the normal vectors of how to find the what when you are using Pythagoras theorem, r is equals to square root of a square plus what? B square. Let's look at this question. Find the magnitude and direction of the vectors 5 northeast and then 12 north north. All what we need to do is what? Your A is 5, your B is what? 12. So as we are having east north. Now. So that means you do what? You add north north. Don't forget. I get him now. So you're going to add R is equal to square root of what? A square plus B square. So mean R is equal to square root of 5 square plus what? 12 square. That gives you square root of what? 25 plus 144 and square root of what? Square root of what? 169, and that gives you what? 13 Newton. So resultant is a Newton, but it's a force. Don't forget. So this one doesn't mean 13 not to, it means 13 what? Newton, which is what the what's it called? Unit principal unit of what? Of force. It's also because the resultant vectors, they are resolution. They are resolute in what? Um in Newton, because they are being calculated based on force. Okay, then we have to find the what? The direction. That means this formula is for what? Magnitude, the size. So what of the direction? I told you theta is what? As tan inverse of what? Ry over Rx. So in this place now, what is our vertical? The vertical, they said east, so we have east, 5 east, and then what? 12 north. So these are our vertical, these are our y, and these are our what? X. That means I'm going to be having what? Tan inverse of what? 12 all over what? All over 5. So, and that will give you what? Approximately 67 degree northeast. 67-degree northeast. That is what you are going to get. So that is how to calculate that. Resolution of vectors, as I've said. Resolution of vectors means splitting a single vector into two or more component vectors that act along a chosen directions, usually perpendicular axis. Why are vectors are resolved? Why vectors being resolved? One, to make calculations easier. Two, to analyze motion of forces in different directions, and also to apply equations separately in each direction. So, how many directions do we have? Of course, we have just two. The common used directions. We have just two now. The x and what? And y. X and what? Y. That's the direction that we have. So now, so we have a horizontal, that is our x axis, and we have what? Vertical, it's our y axis. So, and they are usually what? Perpendicular. Perpendicular means they are at what? 90 degree. So that is it. Okay. How do we now do resolution of a vector in two dimension? Now vector. Consider a vector A making an angle theta with the horizontal. Vector A making an angle theta with the horizontal. So horizontal. So the formula is that horizontal component of AX is equals to A cos theta. A cos theta. Y vertical component, I want to consider the vertical of A also. So our AY equals to A sine theta. So don't forget this. When you are looking for, or you want to calculate horizontal component A cos theta, you want to calculate vertical component A sine theta, where A is our magnitude of the vector, and the theta is what? Angle with the horizontal. angle with the word horizontal. That is what our theta stands for. Okay, let's look at this question. A force of 10 Newton acts at an angle of 30 degrees to the horizontal. Find the horizontal and vertical components. A vector, a force of 10 Newton, force of 10 Newton. So, acts at an angle of 30 degrees, theta is 30 degrees. We have to find the what? The horizontal component and the vertical component. As we say, our horizontal component is equal to F cos theta. That would be what? 10 times what? Cos 30 degrees. So whatever you get, that will be your answer, which will give you what? 8.66 Newton. And to calculate our vertical component, AY is F sine theta, which is 10 times what? Sine what? Sine 30 degrees, which will give you what? 5 Newton. Since sine theta is what? 1 over 2 or 0.5, and this one is 3 over 2. So by the time you do that, you are going to get your answer. Okay. Though the special cases, so the formula you need to just take note of. Theta is equals to 0 degree on the horizontal axis. So theta is 0 degree on the horizontal axis, and theta is 90 degree on the vertical axis. So at horizontal vector, horizontal what? Vector, you are considering horizontal vector. So your vertical component is what? 0. It's going to be 0 from the origin. Also, in the vertical vector, your horizontal component is also what? 0. Here, your vertical component is 0. Your horizontal component is what? Is 0. So, where can we make use of scalars and vectors? Well, all these resultant vectors during projectile motion, the time of flight, maximum range, and all those. For this on an inclined plane, of course, when you're dealing with an inclined plane, you make use of all these formula. Velocity and acceleration analysis, engineering and physics problems. As I note, a vector itself does not change when resolved, either in a vertical or horizontal. It does not change. Only its representation what changes. Okay, so that means now our last topic for this, we're looking at relative velocity. Relative velocity is the velocity of one object as observed from another moving object. In a simple words, relative velocity tells how fast and in what direction one object appears to move with respect to another. So a relative velocity is given as equals to velocity of A minus vector velocity of B. That general formula. So where of A is equals to velocity of object A, and then V of B, velocity of object B. Then AB equals to velocity of A relative to what? B. So here you know sometimes talk about relative motion, that is frames of reference. So if you are inside a bus and then you just peep in from the window or from the window of the car or the bus, you will discover that the grasses or the vegetables or the humans that you are, or animals that you are passing to, they are also following you. No, they are stationary. You are the one that is moving. That is you that is inside the bus. You are relative. Are you what? In position, in a direction to the standard, to those what's it called, the object that cannot move from their what? From their position. Okay. So now let's look at a special cases of a relative velocity. So what you need to take note, if the objects are moving in the same direction, your relative velocity there is going to be difference in velocity. Difference in velocity. Difference in velocity. But if the objects moving, they are in opposite direction, so your relative velocity there is going to be plus. You add them together. Also, so that is a relative velocity. So let's look at position and direction. It is very, very important. Position and what? And direction. So when you say position, let's look at this, in mathematics. So if you have this one, I have this point. This is 3. This is 3. So of course, this is point P. So this point P, we said the coordinate is what? 3, 3. That shows 3 in x axis, 3 in y axis. That is the position of the P. So we also take note of this in physics. What position tells the location of an object relative to a chosen reference point from the origin. That's what makes the differences between mathematics and physics. So from the origin, so you take note of this. You see, so this is our position from the origin, 0 to 3, 0 to 3. Is also 3, 3. That is it. So position tells the location of an object relative to a chosen reference origin. So what position vector? If you want to find a position vector, the first thing is to find the position vector. Represent the position vector by R. So the position vector is represented by this symbol. So whenever I see this symbol in physics, it means position vector. Then drawn from the origin to the what? To the object, as I did like this. So the position vector formula is position vector is equals to xi plus yj. Don't need to be panic. The I means that object, the position it stands in x axis, and where it stands in y axis. Wherever you see I and j in mathematics, so that refers to vector. So position vectors. So and then where r is our what? Position vector. Position vector. Our x is horizontal position. Horizontal position. Our y is what? Vertical position. Vertical position. And our I and j are called unit vectors. Unit vectors. So, example now, if a point is at 3 meter, a point is at 3 meter, 4 meter. So your position vector will just be what? 3i plus 4j. 3i plus 4j. Unless if I have to find the resultant of the position, that's when you can now use what? 3 square plus 4 square. We are now asked to find that. And the last one is direction. Direction. A direction tells which way a vector is pointing to. Is it to the positive side or negative side? Is it northeast, north south, northwest, southeast, south south? So that is direction. So a direction is usually represented by angle theta with a reference axis. A direction is represented by what? Angle theta with a reference axis. And what that reference axis is what? X axis. So a direction is represented in two ways: angle theta in the x axis or compass direction, which are what? North, south, east, west. That is it. So in bearing, when you see north 30 degree east, You should know what it means now. So this is your north, 30 degree, north 30 degree east. That is it. North 30 degree east. That is telling you what? A direction. So the formula for finding direction is what? Theta is equals to tan inverse of what? Y all over x. So that the question given to us 3 meter and 4 meter. If it has to find the what? The direction. So theta will just be what? Tan inverse of what? 4 over 3, because our y here is what? Is 4, and our x is what? Is 3, and that will give us approximately 53 degree. So that is all about scalars and vectors on quantity. Watch, comment, subscribe, and share to others. Thanks very much.